Hello, my name is Kevin Pearies, and today we're going to talk about measuring power and how it's not a guaranteed that your system is healthy. And what do I mean by that? So, as a tech, I would get a call from the network operations center saying, "Hey, Kevin, we need you to go to this particular fiber port on this particular circuit and measure the light levels or the power levels coming into that card or into that device." And then I would invariably do that, right? And so essentially, what would happen is I would do something along the lines of, um, inspecting that connection. And so if you were to picture, just like a network, and this could be, in this particular instance, it could be an office or it could be a terminal on an F2 side of PON. But essentially, let's say that we have an office here, right? So we have our central office. And in the central office, we have our OLT, which is transmitting light down the fiber path to some sort of a splitter. And we'll call this one a 1x32 splitter here. So we'll call this 1x32 splitter. Then, of course, we'll have these individual fibers coming off of the splitter to a terminal. And then from the terminal, of course, we will go to the home where we have our ONT. So from a very high level, this is what we're looking at here, right? And so what do? You measure light levels. So whatever the light level is leaving the office, it might be something like 5 dBm or whatever type of optic you have in there. And then you might have 16 to 18 dB of loss at your 1x32. So by the time it gets to the terminal, depending on the number of splices and connectors and the distance of the F1, we might be at something like, minus 24 dBm. On the power side, and or minus 20 dBm, somewhere in that range, right? Most ONTs are unhappy around minus 27 dBm. This will vary, so you'll have to look it up. Within the company specifications, they'll have a minimum power requirement, that you need to comply to. But essentially, you would go to this location, unplug from the ONT, and read your power level. So if you have a power meter here, and you read your light levels coming in here, you might have something like minus 20 dBm. So minus 20 dBm is all right light for a standard PON system, right? But you're still taking errors. So you might go to this location here and clean fibers. You might go to this location to your terminal and clean the fiber. You might go to your splitter port and clean a fiber. And so why are you cleaning fibers? You're not cleaning fibers to improve power. You're cleaning fibers to improve ORL or reflection. ORL reflection is backscatters, light that comes back towards the transmitter that can create noise. I'm not talking about electromagnetic noise. I'm just talking about signal noise ratio, right? And so power meters only read power. They do not measure or read reflection or the noise created from it. It's almost like, water pressure. You can measure the water pressure, but that doesn't tell you the quality of the water, right? That's a whole different test that you need to do. It's the same thing for fiber. So there are two critical parameters that we concern ourselves with when we're talking about fiber to the home. One is going to be, what is my power level coming into my card or into my equipment? And what is the ORL or reflection across that span? But we're not measuring that. You need something like a reflectometer, like an OTDR, to measure reflection. And so what I've done here is within my fiber network here, I have a power meter here. So I have a power meter here, which I'll go ahead and power it on here. So this is just a standard broadband power meter. This is not a PON power meter. I'm only reading one wavelength. I'm sending light down the fiber within my network across this connector. And then eventually it ends up over here. It ends up over here. So, of course, I want to inspect and clean this connector and plug it in. So I've already done that. So for the sake of expedience, I'm just going to plug it in. So I have this set for 1550, which is what I have for this. If you're doing 1490, you set it for 1490. If it's 1577, you can set it for 1577. So in this case here, I've inspected it and cleaned it, and I plug it in, and I'm reading minus 20 dBm of power, which for a standard PON system is fine, right? Is fine. But if I were to look at this connector here, so here's the connector over here, I'm going to go ahead and look at that connector. I'm going to go ahead and unplug from here. And I'm going to look at this bulkhead connector here. So we'll say that this was the drop or the terminal. Now, of course, it would be APC and it would be OptiTap or push lock or something like that. But in this example, a connection is all we need. So I'm going to go ahead and plug in my fiber inspection probe here. And it's going to go ahead and start to inspect the fibers. So you can kind of see it over here off to the side here. So I'll switch over to my test set here. And you'll see that we have cross-contamination. And so just because you have good power does not mean that you don't have a dirty connector. So it's really important to do both. It's important to inspect and clean your connection as well as measure your power levels. If you have a tool like an OTDR, then you can run a test to look at the reflection of the individual connectors, like at the terminal. But otherwise, it's important to inspect and clean because this right here needs to be resolved. And this can cause issues on your system. You don't have a power problem. You have an ORL or reflection problem, which is a whole different thing. So this is why it's important to always inspect and clean your connections. A simple power measurement is not a 100% indication of the health of your network. My name is Kevin Pearies. Thank you very much.